Recording it now. And questions before we start sharing the screen. We got a minute or two. Anybody got a question on logistics? If maybe I'll answer it while we're talking, and I'll give you a chance at the end to ask questions too. But any question burning a hole in your brain that you need to answer now? Okay, so let me share my screen again. And you can still ask questions as we're, even though the screen's being shared. Now I want to move you guys to the bigger screen up here. Put you in gallery view. Well, we only have 7 so far, so I don't want to get going too much. Let's go chat, open that up. And so on your questions, either turn your mic on and ask them, or else put them in the chat. Okay, now we're up to getting 8 or 9 now. If you can't make the meeting, remember, if you can't make the live version, you can always come tomorrow for second hour's meeting, which is at 9:30, or you could come early today and just jump in first hour. It doesn't matter what hour you're in on this virtual stuff. You guys, you can see me, right? You can see me, yeah. So you can see me in the corner. That's good. Because when I record it, when I do my thing, that's one thing bad about it, because you can't see me. And I'm trying to hold up fingers and stuff, and people can't see me. So this might be better for that reason too. So I am going to record this. Now, I see you, but nobody else on the recording will see you. You won't show up unless you take over the thing. You wouldn't show up, as far as I know. All right, so let's go through some announcements. We got to get to something totally new today. Let's do it while people are still joining in. Let's do a couple of announcements here. Now, it looks like next week we'll be at same virtual. You know, I think if they would just kind of do the same thing for 3 or 4 weeks at a time, we'd get better at it. I'm better now. I'm a little better at virtual than I was. If we do alternate, I'll get good at that. And you'll get good at that. But we keep changing. Anyway, so next week we're still virtual. And then the next week we're back. So the next week's 5 days. The week after that is 3 days for fall break. And it looks like we're going to go, this is still, it's alternate, but I think it's going to be, my guess is group 1 virtual on Tuesday, then group 2 on Wednesday. That's my thinking. We'll find out more details on that later. And then the week after that, after fall break, the plan right now is a very optimistic plan, but they're saying we're going to go full Monty, the whole thing, full throttle, traditional schedule. And that's why teachers are starting to put the resumes in and looking for other jobs right now. And I kid you not. You may come back after fall break and your teacher's not here anymore, but I'll still be here. But I know of at least 5 that are actively seeking other employment right now. So we'll see what happens. Good news, I pushed back the due dates for the take-home test. It was supposed to be due tomorrow night at midnight. I pushed that back to Sunday, partly because I'm going to be camping, so I won't be around for a good part of the weekend. So we'll talk about that more later, but I pushed back till Sunday at midnight, and then what was due, 1.6 was due Sunday at midnight. Well, I kind of figured there's no way first hour didn't get through the whole thing. So we pushed that back till at least Tuesday at midnight of next week. Like I say, on these due dates, I'll never move them up. If anything, if they change, it means they got pushed back. Okay, I start off optimistic. Also, when you're going to the Facebook group, people are starting to go there and ask more questions, which is a good thing. but I get alerted. I may not see your comment. I may not see your question. I just kind of scroll through. Maybe I don't see your question. But if you put one of these three things in there, I will be alerted that you have a question, and it says right there when I open up my laptop, go to answer their question. So that's what you want. You want your question answered in a timely manner. I saw some students, and now I've seen them kind of scamper up to my porch, look around, grab some paper, and run. So I'm guessing you're getting the test. So it's still there. I still had some bait left out. There's two girls. It was like they were little squirrels, and there was a trap, and they were making sure that there wasn't a trap set for them. They looked around, cased the joint out, ran up, grabbed them, and ran. I'm not gonna get you. Anyway, it was entertaining for my wife and I. We did a review. A lot of you were there yesterday morning, and that's now taped, and that is now in the Facebook group. I also put a link to it, I think, maybe on the Canvas, but it's definitely in the Facebook group. Okay, so you're supposed to have worked 1.6, 1 through 7. Now, before we move on to number 8, is there any questions on 1 through 7 that I can help you with? There will be a key posted, but that'll be next week. So if the key is posted after it's submitted. Any questions on 1 through 7 from 1.6? Now, if you're looking at me like, what are you talking about? You need to keep up a little better, just to stay on pace. Okay, Jacob has a question. On number 3, do we just write the equation for Joe Dynamo's journey? Yes, that's all we're doing is you're writing the equation. So Joe Dynamo, if I go on that one, let's quickly look at it. If I go on the Corvette, I'll make that green, and you just got to give me the old slope intercept form, the physics version, right? The red equation. So we say, okay, that's x of t equals, and now I need my slope. Well, I'm gonna get the low-hanging fruit. The low-hanging fruit is the initial position, which in this case is simply 14 kilometers. So I know I'm gonna say plus 14 kilometers. I think I got in that habit of low-hanging fruit when I was in college taking physics tests, because physics tests are timed, and mine are timed too, I guess, but they always give you, there was always 21 questions, and there was enough time to do about 15 of them. So you had to do triage on every question. Should I even go with this, or should I skip it? And that's the way AP exam sort of is as well. But so I'm always trying to grab all the simple points I can get. You learn that it's like you're trying to survive. So you go with simple points. That would have given me partial credit, right? Even if the professor says time, I've at least got a point on this. So that's why I go low-hanging fruit. And now I do velocity. Velocity is that slope of the green line. Well, we do a rise over run for the green line, and our rise is really a fall. It falls 14 kilometers in 40 seconds. Okay. But remember, you can't leave it as 14 negative. In that case, it's going down. Negative 14/40. That's a big no-no. So because you can't leave things in fraction. We had this discussion. So that's 7/20. That's, or 0.35. So the slope is negative 0.35 kilometers per minute times t. You have to have the t in there to make it an equation. And that is your answer, okay? Now, first hour, they were giving me thumbs up. And so if I say yes or whatever, then you just hit the thumbs up button on your, that way I know you're awake too, so. The other one they asked about is number 2, and they said, how much faster is a moped in the slope than the bike? And you're just comparing slopes. You compare slopes there. It's all you're doing, okay? And there's no reason to convert it to meters per second. Just leave it in kilometers per minute. All right. So we got to keep moving here. We got a lot to do today, but 7 was the thing with the fly. So keep thinking about that. Just because we end at 11:40 today doesn't mean you can't still get help. You still, I'll be around through tomorrow morning. I'll probably leave for about 11 a.m. because I got to go get the trailer ready. We're going to take off for Keystone Lake about 1 or 2 in the afternoon on Friday, and I won't get back till Sunday at 5 or 6. So I'll be out of pocket. There's no Wi-Fi where we're going. So you can ask questions, though. My point there was probably tonight and this afternoon are the best times to ask questions of the take-home when I'm still around. All right. Now let's go to number 8. There's not one like 8 on this take-home. It's on the take-home 1B. There'll be ones like number 8. The B part of the take-home is always harder than the A part. Rule of thumb, anyway. All right, so we talked about this. We set this up last time. Here's Donald Trump walking down. This is when he first gave his candidacy in 2015. He's walking down the aisle at 20 feet, at 2 feet a second. And this is just a profile view, this image here. So he walks at 2 feet a second. And so let's split this up into 2 parts. The part where he's walking down, I'll go red on that, where he's walking down the aisle horizontally, and then the part where he's going down the escalator, and I don't know, let's make this blue. No, not blue, let's go green. So we're doing this in 2 phases. You guys ever, well, it's a little like a piecewise function. You guys ever learn of something called a piecewise function? And so if I see your video, you can nod your head. But if I can't see your video, you got to have your finger on the thumbs up button or thumbs down. It's okay to give me thumbs down too. So yeah, okay. So it's like I'm communicating with an alien race here. We've established that we have a yes or no. We got yes or no now. All right. For those that aren't on video. So this is the red part. Let's kill that. Hold on, excuse me. I'm gonna kill this again. That gets in my way. Okay, so this is the red part. I'll just highlight that in red. And this will be the green part. The thing about physics, you get to color stuff every day. Woohoo! Got to take your joy where you can find it. Okay, so now we're going to do a red phase, green phase. So the red phase is him just walking down the aisle. So that's the easy one. Let's get that out of the way. So he's going along in the X direction, positive X direction. Now, someone asked last hour, well, should we do like an I roof, J roof? And the answer is no. It doesn't hurt if you do, but you're setting yourself up for making a mistake. So be careful. When you volunteer information and it's wrong, you lose points. So like on a test or something, sometimes students want to show me how smart they are and they start going on, well, then that extra stuff they gave me was wrong. So now I got to take off. So sometimes it's better just to not say anything on a test. Say all you want in class. Okay, so the red part, let's go back to my ruler. He's going at 2 feet a second. Black. He's going at 20 feet down the aisle at a speed of 2 feet a second. That's his velocity. That's his delta X. And that's all. That's all we know for the first phase. That's it. So this is like the simplest stuff we could do in here, right? He ends up 20 feet away. So I'll pick a point. This is a sketch. So 20 feet away. Stop me with questions anytime you want. So that's 20 feet. I'm trying to make, please tell me wait. Am I recording this? Yeah. Woo. Good. Okay. So I'm trying to make this nice for the recording. And he gets there, he's moving at 2 feet a second. So how many seconds, if he's going 20 feet or 2 feet a second, somebody type it in, or you can turn your mic on. How much time will it take him to get there? Thank you. So Jacob's saving our bacon here. So it's 2 feet a second. So then it's going to take him 10 seconds. So I know this is at the 10-second mark now. And the slope, just for grins here, the slope is equal to 2 feet a second. The slope, remember, slope is speed. So far, so good. Now, what's going on in the Y direction? When he's walking down that aisle, in this spot right here, the red, what's happening up, down?
Nothing.
It's asleep, and Logan's using the correct term, so I guess we talked about it yesterday, or day before. It's asleep, or Monday. It's pretty good memory. Or he wrote it down. So the way you show an axis asleep, just put a flat horizontal line. I chose a poor color. I was sticking it up. So that is asleep. Okay. First part done. We'll call this phase 1. I mean, maybe you all talked about it, but maybe somebody in second hour didn't, and we're making a video here. So we have a studio audience eventually. So now we go to the green phase, and now it gets a little bit harder in a hurry. Now he's going down an escalator. He hasn't changed his speed. He's still going at 2 feet a second. So down the escalator, let's put what we know, okay? So down the escalator, it says he's still moving at 2 feet a second. Uh-oh. In the hypotenuse direction, he's moving at, his V is 2 feet a second. But I can't say Vx or Vy. That's like V sub S. Because this is delta S. Delta S is 26 feet. Remember, S is when you combine X and Y. Or X, Y, and Z. That's S. But what I cannot plot, I don't plot S per time. You got to keep it in terms of I roofs and J roofs so the computer knows what you're talking about. So this is my delta X, and this will be my delta Y. Okay? So we got to figure out what is my delta X and what is my delta Y. Now I know you got shortchanged on Algebra 2, but I think you at least got to 30, 60, 90 right triangles. I know you talked about that in geometry. It's been a while, right? It's been a minute. I think that's what kids say for geometry. But remember 30, 60, 90 right triangles? If that's 30, that's understood to be 90. So therefore, that's 60. Okay? So on a 30, 60, 90 right triangle, remember what the short side is compared to the hypotenuse? Anybody want to shout that out or type it in? Or hold up your fingers and your toes. What would be the length if the escalator is 26 feet? How far down did he go in the escalator? So I want to know this. Only want to know the y. I want to know the y length. So I'm going to break this up into a blue part of the right triangle. Let's try again. Blue. Okay. So the blue part, hypothetically, it's 2 rooted. It's easier than that. On a 30, 60, 90, it's easier than that. So I'm picking that up here. So I'm talking about this axis, or sorry, this leg. These are called legs. And usually I do my Y as blue and I do my X as orange because that's the color of the equations. Orange. Find an orange. There it is. Okay, so I'll make this orange. All right, so we got an X and we got a Y. So what is let's do the, once again, low-hanging fruit. On a 30, 60, 90, this is a 30, 60, 90. And that would be pretty good if you all can remember this, but you'd be pretty smart if you could remember all this. But the side, the short side, the short length, remember what its relationship is to the hypotenuse? Right, so Ronnie got it right. It's 13. To be more precise, negative 13. It's always half. So this is negative 13. You've got to put units there, feet. So the short side is always half the hypotenuse. And then what about this side over here? What about the X? That's harder to remember. But this will be 26 feet times root 3 over 2. I think that's like 0.717 or something. So somebody punched in, that's 13 times 1.7. I think it is. I don't remember what that was. Somebody punch that in and write that out. Let's go be 2 siggies, 2 siggies. 2 digits is all I need. And how do I know root 3 over 2? That is a geometry thing. It's a formula they've known for about 4,000 years. It's just one of those things that's always the case in a 30, 60, 90 right triangle. So you punch it in, it's 13 root 3. What's 13 root 3? Somebody help me out. Somebody help me up in here. 13, you guys are slipping, you're slipping. 13 times 1.7. Put down your cornflakes. 22, about right. To 2 siggies. 20, we're going to keep it simple, right? That's 22 feet. So tell me if I'm wrong. Okay, Natalie agrees. 22 feet for 2 sigs. All right, so that helps. That helps. Now, the other thing we need is time. How can we find out how much time it took to go down that escalator? And you can turn on your mic and free form here if you want. You can actually have a real live discussion. That's the beauty of, I mean, if all you're doing is watch me, you might as well just watch me on YouTube. This is a cool thing. You can interact with the teacher, which you're paying me a lot of money for.
We know it's going 2 feet per second.
Yes. Now, how did you, who's talking to me?
Rose.
Oh, Rose. Okay. How did you know that? We're going to 13 seconds, you said?
Oh, we're going 2 feet per second.
Yes. And so we go 26 feet. So 13, right? Okay.
Yeah.
So therefore I know that, just divide it. So I know, because I know that T in this case, I'm trying to make this nicer because it's a video, recorded video. It was pretty sloppy first hour, I must admit. T then is delta S over V sub S. Notice I got to give it V sub S because there's a V sub X, there's a V sub Y. So T then is going to be 26 feet divided by 2 feet per second. And notice, kill that. Kill that. Boom, boom, boom. Okay, so 2 feet per second. Notice that when I do that, when I divide it, the feet will kill each other. That's the green kill pin. The feet kill each other, but the seconds, 1/1 seconds becomes seconds up top. And so I end up with 13. That took 13 seconds. You say, well, Mr. Askey, I did that in my head. Okay, but I'm just showing you the units. Okay, so I know now on my time. Let's go back down to my graph. This thing started off real easy in the red phase. All of a sudden, the green phase, not so easy, huh? Phase 2 here. I know that it took me 13 seconds. So when I add them both up, I'm going to be at a 23 seconds. This is like a piecewise function, which I think you've heard of. So 23 seconds. Oh, so now let's see. Oh, boom. Okay, look. I know that in my X, looking at that, I know that my X went 22 feet. So I went 22 feet in 13 seconds. Okay, well, I can plot that. Okay. Okay. That seems different than we got in first hour. Now I'm getting a little concerned here. 22 seems okay. Is that right? That's what I got too. Okay. So we agree there. Okay. So anyway, now you plot it. Plot for me. Try it. I'm going to give you a minute. I'll shut up for a minute, and I want you to plot what goes here. Do it in pencil, okay? What goes here and what goes here. Do it lightly in pencil. Then it's an easy erase. An easy erase job, okay? So do it lightly in pencil. I will shut up for exactly 1 minute. Unless you ask me a question. I'll kind of work silently over here. You know, if you're just sitting there waiting for me to give you the answer, I won't be doing that on a test, man. The test is 300 stinking points. You know, everything's rosy until the test comes around. So it's better for you to do it wrong. You go, oh my God, I can't be wrong. I'd feel bad about myself. Would you rather be wrong here, whereas no, or lose, you know, 150 points on the test? That doesn't look good at all. I wasn't even playing Greek. Let me fix this. Okay. There, that's better. Well, it's not beautiful, but okay. So I'm going to overlap. It looks like daggone it. Okay, do you have something? Let's do the Y. Let's do the Y. So on the Y, if we go back and look at this, and the Y, now we know everything we got to know. We know that the Y went, it went negative 13 feet in 13 seconds, right? Negative 13 feet in 13 seconds. So do a little quick division. Even I can do this without a calculator. That's -1. So I come down here. Dang it, sorry, I got to stop those. So that's negative, sorry, man. I got to turn notifications off on my iPad. I think my niece got some new puppies, so her kids are going crazy. It's all about the puppies. All right, so this then is, oh, it's a Chihuahua mix. All right, Chihuahua Dachshund. So this then, Fredo and Diego. Okay. Are you guys seeing these? Are you seeing these messages pop up on screen? Daggone it. Okay, I'll get that fixed. Sometimes the messages aren't about puppies and Chihuahuas, man. Sometimes it's a little bit more, shall we say, colorful with my family. All right. Might violate some communication laws. But we'll take a chance today. They're in a good mood. So there we go. That's the graph in the Y. Picking that up there. Make it pretty for the camera. Okay, that's the graph in the Y. And we know that we dropped 13 feet. And this is not the scale, by the way. It's not the scale. This is a sketch. But we dropped 13 feet. My delta Y was negative 13 feet. And my time was 13 seconds. So this slope, therefore, is equal to -1 foot per second. Okay. Now on the phase for the X, now that we did this, now you do the X. Do the same thing on the X. And while you're doing that, I'm going to try and turn off my notifications. Group me off. No. Okay, yeah, group me's off. Let's go messenger. Off. It says it's off. Oh, messenger. Okay, there you go. Off. Okay. That takes care of that. Okay, so you're supposed to have done the X now, or tried it, or thought about it. And this is where I'm going to be in trouble. I'm going to overlap a little bit. But X, see, no longer is he still going 2 feet a second. He is going 2 feet a second. But if I take my X goggles and, okay, say these are my X goggles, and I'm looking at it just in the X direction. Like if I put my Y goggles on, like it's polarized, right? And I can only see things that are vertical. If I'm looking at him, all I do is he's, in the first 10 seconds, it's just, DJT, you know, he's just Donald Trump sitting there because I can't see, he's not moving up and down. So he just seems to be sitting in place. But then at the 10-second mark, he starts to go down very slowly, like he's on an elevator, because I can only see in one dimension. And he starts to go down at 1 foot a second for 13 seconds. And so at the end, I go, okay, he's dropped 13 feet. But I can only see in one dimension. So I have the misconception that he went down an elevator, okay? Now I go back and I put on my X glasses, X goggle here, and I'm looking at the telescope. So I'm looking at him, and I'm watching him, and now I see him going along like he's supposed to at 2 feet a second for 10 seconds. But then at that point, he seems to miraculously slow down. He slows down in the X, but you go, Mr. Askey, he doesn't slow down. But he does slow down in the X direction because his velocity is a vector and it gets divided into the I roof and the J roof, into the X and to the Y. Conservation of energy says he still has to keep the same energy in the system, but it gets divided up into X and Y. Yeah, so Logan stress down 13 meters in the Y. But in the X now, he goes 22 feet in 13 seconds. And so what is that slope? What's 22 divided? So V sub X V sub x here equals 22 feet divided by 13 seconds. V sub y was 13 or negative 13 feet divided by 13 seconds. But now V sub x is 22 feet divided by 30. Okay, so what did we get there? Somebody punch that in. 22 divided by 13. Less than 1. You get about 1.7, right? So, whoa, no, it's not less than 1. It's less than 2. I'm sorry. So it's 1.7 feet per second. So he was going 2 feet a second, and I'm looking at my X goggles. I'm watching him go at 2 feet a second, and then I'm going, hey, I got my buddy over here. Hey, Joe, Donald, slow down, because all I see is the X, okay? I don't realize he didn't slow down, but in my opinion, he did, because I can only see the X. So on the graph, it's going slower. So on the graph, you go, okay. Okay. So on the graph, I lost it. There it is. Technical difficulty. There it is. On the graph, then, I have a slope. Hey, can you guys see my ruler? Okay. So I'm going to take that ruler now, and I'm going to change it. This is a sketch. But I'm going to change it slightly because I went from a slope of 2 to now a slope of 1.7. And so it looks like this. There's a slight jog, a little glitch. I'll make it a little more pronounced than that. There's a little glitch in the graph. And let me go to there. So I ended up going a total of 42 feet. So this is not the scale, but I'm at 42 feet. I ended up going in the X, 20 feet to begin with, plus 22 feet horizontally when he's in the escalator. And I did all that in 23 seconds. So the slope here is 1.7 feet per second. Okay. Woo, all right. That was that problem. You can see that part B on the take-home test is going to be a little harder. We got a couple of these. Well, good. Now we're going to get to, we're way behind schedule. We're going to get to I spent a lot more time on this than I did the first hour. But you don't rush physics. Now okay. Let's skip that. So now we're going to get to, by the way, there is help videos on two-dimensional motion. There's 2 help videos. They're in the Facebook group. They're also in the introduction to sheet 1.6. There's also one on circular motion, which we're about to talk about. Okay. So we're now on the back of 1.6. We're going to spend all our time just messing with number 9 today. That's all we're going to have time for the next about 20 minutes or so, 17 minutes. So we're talking circular motion, and circular motion is called, we call it, we divide everything up in colors. Circular motion is black kinematics. So we've been dealing so far with red kinematics. Red kinematics is movement without, it could be even circular, it's linear movement in without any acceleration. So it's all linear stuff. It's regular, it's linear movement with no acceleration. Okay. But black kinematics is circular motion. So here's my representation of black kinematics. All right. So do you guys see that little puppy? Since speaking of puppies, you guys see that little puppy? Can you see it? Is he moving around? Okay, so that is my, that's not Pepper, that's not my dog, but that we have a little miniature dachshund just like this. And that was Pepper 17 years ago. But Pepper's now couldn't begin to run, he barely can walk. but she had a rough time last night. She was up. My wife finally fessed up, and she gave her 2 Chick-fil-A chicken nuggets as a treat. And she threw up and diarrhea everywhere. So she was up all night. Her stomach was killing her. So anyway, but this is a good introduction to circular motion, because that's what that little puppy's doing. So when I'm trying to figure out the puppies, and this helps because now that I can do GIFs, it's going to make, physics is all about GIFs, all about motion, right? We're studying motion. So it's kind of good. Now I can add more GIFs to our Zooms. But when I'm looking at that, I can do some timing here. And that puppy, I just pulled this GIF up last night, but that puppy is probably running at, how many revolutions per minute do you think that is? How many RPMs? And RPM is omega. We could actually time it and see, but I'm going to say that's probably takes, let's check it out. 1001. When he gets that little pink, when he gets to the pink pig, okay, we'll start our timer there. And 1001, 1002. So it looks like it's going about 2 revs per second, right? So that would be 2 revs per second, 120. That's 120 RPM. So is the that's the way that's like layman's terms. But we have to talk about it in terms of something called omega. Okay, so let's go back. And all of these have to do with pi as well. Any circular motion, you're going to have a pi in there. So let's do a quick demo here. Thrown together demo. So I got a circle here, and I think hopefully you all did this in your math class, either in 7th grade or 8th grade. Or I take a USB cord here, stick it on that, wrap that thing around. Okay, wrap that around until I get back to, there it is. So that's that length. Now I'm going to mark that length with an expo marker, a clean expo marker. I'll mark that length. Okay, I'm going to rub it off. And now I take this cord and I'm going to measure. I'm trying to put the lid back on. I'm going to measure this. So that's my circumference. Now I take this and I go, okay, there's the beginning, and that is 1 diameter. Put my fingers there. That's 2 diameters. That's 3 diameters. And a little left over, there's my red mark, that little pigtail, that little bit right there. And what is that little bit? All right, I got a better prop. All right. Frisbee. Okay. We like to play a lot of Frisbee outside. All right, so now I do a Frisbee. I'm going to show you the circumference. Okay, I got a blue cord here. Go all the way around. And notice that is the circumference. All the way around is 1 circumference, okay? Now I take that cord and I take it and I go 1, I go 2, I go 3, and I got a little pig's tail. How much is that pig's tail? You got to say it or you got to write it. Thank you. Okay. So Avery gets the, Avery's the quick one there. I'll give them both. There was a tie. I'll give it to Avery and Natalie. 0.14. They knew that because it's pi, right? 0.1415, et cetera, et cetera. A lot of you guys can go out, 30, 40 digits. So that's cool. But that's like, we didn't figure this out in the 1950s. That was, the Babylonians knew it. I mean, the Greeks knew it. The Egyptians knew it. So pi, it doesn't matter what the size is. If I want to take this little guy, I can do the same thing. And it's 3.14. The circumference is always 3.14 times the diameter. And if you want to make a little video of this, you get some points out of it, put together a little, be creative about it, and just, you know, take a pie pan, take a coffee cup, okay? And you can do that. It doesn't matter what the size is. It's always the same. It's always 3.14. And that's a weird oddity with circular motion. But that's what we use. That's why we use pi. Pi is the reference point for circular motion, okay? Everything's always in terms of pi. Because when okay, let's keep going. So I did it last year. I did it with some disinfectant wipes, but we've used those, of course. So when let's talk about pi and omega at the same time. So here's an old LP, and when I was in high school and college, I collected albums, and I have some of my album collection up here. Look at this. This thing's worth something. That's the Beatles. That's the original. This is the original Beatles album. Meet the Beatles. See, this album's worth something. Anyway, so you take these things out. Let's take the Beatles album out. Yeah, sure enough, this is the original album. But the first press, I mean, this is one of this, my brother got this one. But on this album, we have like we say, a fly lands. These are called LPs, right? Anybody know what LP stands for? Type it in, LP. What does LP stand for? Who's ever quickest at Wikipedia? What does LP stand for? Too slow. Long play. Brittany threw it in there. Long play. All right, I'll give it to you. So long play, and then what? Long play. What's short play? Well, we had 45s, and so you'd go out and buy a 45, which was a single, and then you always had the B side. So the hit, like the Beach Boys, would put out a new one, and we would all run down to get the Beach Boys' new single, Surfer Girl or something. And then on the B side would be some other song. So there was so the cut was, oh, that's a B-side song. Anyway, so long play, you put a whole album together, and you get groups like Led Zeppelin, you know. Here's Physical Graffiti. So Led Zeppelin would put out these albums and called album rock. Wow. Anyway, so point is, this is 33. This would be 33 1/3. This is a LP. It's also called 33 1/3. Now, what does the 33 1/3 mean? That means that it goes around 33 1/3 times per minute. So it's a 30. Sometimes they call these a 33. They call a 45. It goes around 45 times a minute, and then a 33 goes a little slower. But you have grooves in here. It's all physics. I mean, music is all physics. Okay, it's really cool how they make LPs, but we don't have time today to go into that. So let's say a fly is on that LP and it's going around. Well, I've got to figure out its velocity. But we don't do it in terms of meters per second or even feet per second. We do it in terms of revolutions, but RPM is a layman's term. It's, you know, like on your car, right? If you're driving down the highway, you have a tachometer. And the tachometer, you have an odometer, measures how many miles you've gone. You got a speedometer. You have a tachometer. And a tachometer is measuring how fast the drivetrain's turning, right? So a typical going down the highway in overdrive, you have it on cruise control, you're not on a hill, about 2,000 RPM, okay? That's a typical engine, spins at about 2,000 revolutions per minute. You crank it up, you goes down to a lower gear because you're going up a hill, it'll bump up. You'll hear your engine roar or rev, and that goes to 3,000 RPM. You get it to 4,000 RPM, now you keep that up for a long time, that's engine damage. Your red line at 6,000 RPM on a typical car. Like if you have I used to have a sports car, I had an RX-7, and I'd redline that thing, which is good to clean out the pipes. But that gets around 6,500 RPM. But we don't, that's for auto mechanics, but we don't deal with auto mechanics. We're dealing with pure physics. Pure physics would never use RPM. We use radians per second. So the symbol for speed in circular world, for black kinematics, in linear world, okay, for linear world, we have V, right? We have V. V equals delta X over T. But in circular, in black kinematics, circular world, we have omega. Omega. And omega equals not delta X per time, but something called delta theta per time. So there's a new equation for you. It's analogous to the red kinematics, but it's things going in circles, like this fly on an album, like that little puppy. We can figure out his omega, all right? Okay, so let's go back here. How much time do I got? I still got, I'm gonna go to 11:36, give me 5 minutes, okay? I'll go to 11:36, 11:37, okay? And then the last 3 minutes, you can ask me questions. So we're almost done. This is from last hour, I'm just looking at my notes. Okay, so I guess I can show you all this now. So here's what we talked about last hour. Capital omega, you know, is that weird symbol there. But this is a lowercase omega. And we call this the baby's bottom because it's not a W. Don't do W. W in physics stands for something called work, which is a huge concept we'll get to second semester. It leads us to energy and how machines, but that's W. So don't use W. It's a curve. It's a curvy right here. See, it looks like a baby's bottom. So we call it the baby's bottom. That's a lowercase, like Greek symbols have uppercase and lowercase like we do, like Latin does and like English. But this is a lowercase omega. Okay. So then we said that omega is like speed for things going around a circle. So we say omega is delta theta over T. Now this is called theta. Theta. You have to learn the Greek alphabet in physics because gamma, beta, alpha, all those things mean something in physics. Like alpha particles are helium atoms without the electrons. It's what Rutherford used to figure out that there's a nucleus to an atom. So alpha particles are real important historically. Beta particles are electrons that are escaping through radiation. That's called beta radiation. Another big thing in history. And this then, so that's theta, this is omega. And that's the relationship. So that is a black kinematics equation. We'll hang it from the ceiling, like we hang like if those that have been in my classroom, we have the red equations, right? We'll hang the black equations as well. Okay. So let's look at this real quick. So for the definitions, theta is in terms of something called radians. Those are radians. And first hour gave me a lot of thumbs up that they'd heard of radians. So I'm going to assume you guys have heard of radians. This then is arc length. And this is radius. So it's weird. Here's a weird thing about radians. Radians, arc length is in terms of meters. Radius is in terms of meters. So you do the old green kill pin and they kill each other. So there's no units on a radian. So radians have one thing weird about them is this is really a very convenient, by the way. They have no units. Okay, so this is the relationship. Hey, why do I use a delta S up here and not a delta X or a delta Y? Somebody want to, we got to hurry, we got 2 minutes. Roman's got the answer. Why do I use a delta S instead of a, oh, I thought you were chiming in, Roman. Oh, okay. Roman typed it. He said it's because it's circular, right? And Jacob said delta X, Y, and Z, right? So both Jacob and Roman are correct. I'll give them both a zoom point each. And once again, you guys are keeping track of that. I'm not. So it's because it's a combination of X, Y, and Z. In this case, just X and Y. Remember, a circle. The formula for a circle is X squared plus Y squared equals R squared. But when I add those up, that is an S, or arc length. So when I divide the arc length by the radius, I get 1 radian. And now let me show you my last thing. I'll show you this animation. Hold on, last minute, don't leave yet. Okay, and this is off Wikipedia. If you go to Wikipedia, type in radian, you'll have this on your computer. But there's the radius, okay? Go 1 complete revolution, you got a circumference. If I take that radius, you guys can see the screen, eh? You're watching the animation? Okay. I can see the radius. The radius, if it's curved into so that the arc length is the same as the radius, and then you divide that by the arc length, that's 1 radian. It's kind of messes with your head. It's a little bit abstract. But then I get 3 of those, or 3.14 in 1/2 a revolution, 2 pi radians in 1 revolution. And so we'll watch the animation one more time. Starts off with a point. Okay, you got a point there. We got a radius. Then we take that, we go all the way around that circumference, the blue circumference. There's my R. I take that R. I now tattoo it onto the circumference. And then R over R, it's like delta S over R is now 1, and that is 1 radian. It's about 57 degrees, okay? If you wanted that. And then you go 3.14, half gives me 180, and then all the way around, 1 complete revolution is 2 pi radians, okay? So back to my puppy, last thing then, back to the puppy, we can now determine the puppy speed in radians per second. It's the last thing we're gonna do. I know we're out of time. So I said that it took him about 2 seconds to go 1 complete revolution, right? So I would say that the puppy's omega is 2 pi radians in 2 seconds. And so omega is in terms of, in this case, would be pi radians per second. That would be the puppy speed. Pi, that's how you would say it. Pi radians per second. Okay. All right. Let me turn this off. So we're down to about a minute or 2. Anybody got a question before we, and I will post this. I have to wait till tomorrow's second hour, but I'll post this by noon, probably 11 a.m. tomorrow. And I'll also post the screenshots. I don't know how I'm going to post that puppy, but somehow. Okay, so you all are being quiet. You are talking to me through the chat, which is nice.
Oh, I had one question.
Yes.
So when we turn in the test, are we going to take screenshots?
Wait, you mean the take-home test?
Yeah.
Okay, so you're going to turn in. So Brittany, what you'll do is you'll just take a picture of the front. You'll take a picture of the back. You'll submit.
Okay.
I thought about doing it per question, but oh my gosh, now all of a sudden I got 10 pictures, and each picture takes 10 seconds to download. Oh my gosh, so no way. So yeah, you'll take a picture of the front, a picture of the back. I will then Sunday night, probably Monday, by the time I get to it, I'll start grading that. And I like to have them all graded by Tuesday, because then Tuesday or Wednesday, then Wednesday I'll post a key. And you still have your paper copy. So then it's your job to go look at the key and correct. Okay. If you don't do it, I won't know it, but then you won't be studying the right stuff for the test. Because the test is 300 points. That's the bad news. The good news is you have an amazing scouting report, because I will write the test from the take-home. It won't be the same questions, but it'll be the same concepts. Okay? All right, good question. I'm now over my time. Teacher's gonna get mad at me if I don't leave now. I could post a video, puppy. I might if I could find a way to do it. Okay. You guys were a great audience, a little quiet, but very respectful. I appreciate that. So I will see you guys. I'll see you on Facebook this afternoon or tonight. There's no Zoom tonight. Oh, stop. Don't leave. Oh my gosh. So we have the homework assignment here, but don't worry about the finishing 1.6 yet. We'll just leave 1.6 alone. Make sure the front's done, but the back, don't worry about it. That'll be due Tuesday at the earliest. But what you got to concentrate on from now until Sunday night is the take-home test. But for first hour, talked me into doing another Zoom. We did a Zoom yesterday morning that helped everybody, I think. And if you didn't go, that video's there. I'll do a Zoom and record it, but let's do it. I don't know when I'm gonna get back Sunday. I think around 5, but let's go 8 p.m. Hope it's not too late for you. Let's go 8, and I'll post this announcement. But 8 to 9 p.m., a live Zoom. Hopefully you're wrapping up things on your take home. And maybe you stay for 5 minutes, you get your question answered, you move on. But hopefully you don't start it then. It's due at midnight. So there'll be those that will just wait till then to start it, but that's what always happens. So we'll do that Zoom Sunday night, 1 hour, 8 to 9. Okay, just exclusively working on the take home. No announcements, nothing like that. Just the take home test. Optional, of course. So I'll see you. I'm 2 minutes over my time. I'll see you guys through Facebook or Sunday night. Oh, yes, Logan, I'm going to record it. I think I'll always record those take-home test help sessions, because that's all going to be screenshots, and why not record that? Yeah, you work Sunday. So thing is, though, it's due Sunday at midnight, so I don't know what your shift is, but this is not going to be recorded, but it takes an hour to post, so it won't be posted. The earliest it'll be posted is probably 10 p.m., and that gives you 2 hours to submit. So, oh, okay, so Logan, what I would do in your case, you work till 10, I would go ahead and just get as much as you can done, and then come in at 10 and quickly look at see if there's any kind of corrections you got to make, and then post it. Remember though, you can post it totally wrong. I'll spot check, and you might still end up with like a 60 out of 75, even though it's totally wrong, because I'm giving you a lot of participation points. All right, guys. See ya. Sorry for going over. Have a good day, everybody. Bye-bye.